In this lesson, we want to review solving rational inequalities. So when we solve rational inequalities, we follow a similar process as when we solved quadratic inequalities. So if you've got the process of solving quadratic inequalities down, this will be pretty easy for you. All right, so solving a rational inequality. The first thing we want to do is we want to write the inequality so that 0 is on one side and a single rational expression is on the other. All right, so after you've done that, the next step is to create two equations. We want to set the numerator and denominator each equal to 0 and solve the resulting equations. So the solutions are going to give you your boundaries, or again, some people call these critical values, some people call them endpoints. Now we're going to use the solutions from each equation to set up intervals on the number line. So this is the same thing we did with quadratic inequalities. Now we're going to use test values to find intervals that satisfy the inequality. So the reason this works is that if you pick a value within an interval and it satisfies the inequality, then every value in that interval is going to satisfy the inequality, okay? But the reverse is true. If I pick a value in an interval and it does not work, if it does not satisfy the inequality, then no value in that interval will. Now, when you choose your test values, you cannot pick the endpoints themselves, okay? Those have to be considered separately, which is what we're saying here. Consider the endpoints separately, okay? Now, if you have a strict inequality, strictly less than or strictly greater than, the endpoints or the boundaries or the critical values, whatever you want to call them, are always going to be excluded from the solution. If you have a non-strict inequality, so a greater than or equal to or a less than or equal to, then essentially when we set our numerator equal to 0, those values that satisfy that equation are going to be part of your solution, okay? But if it's the part where we set the denominator equal to 0, remember, if we set the denominator equal to 0, those solutions make the denominator 0, and that gives us division by 0, which is undefined. So those values, those endpoints, those critical values, those boundaries have to be excluded from the solution. All right, so let's go ahead and start out with 7 over x plus 5 is greater than or equal to, we have 8 over x plus 6. Again, what I want to do, I want to have a rational expression on one side and 0 on the other. So if you get something that sets up like this, all we're going to do is subtract 8 over x plus 6 away from each side of the inequality. Again, you can do that because of the addition property of inequality. So on the right-hand side here, this is going to cancel and become 0, which is exactly what we want, okay? On the left-hand side, I'm going to have 7 over x plus 5. And then minus, we have 8 over x plus 6. And again, I'm going to have this is greater than or equal to 0. Now, we know how to add and subtract rational expressions. We just need to get a common denominator going. So the least common denominator is the product of these two denominators. So x plus 5, that quantity, times x plus 6, that quantity. So let's go ahead and do this. We're going to have 7 over x plus 5 multiplied by, this denominator here is x plus 6, so it's going to be x plus 6 over x plus 6. And I'm going to wrap these all in parentheses. Then minus, you're going to have your 8 here, and this is over your x plus 6. And I'm going to multiply by, the denominator here is x plus 5, so x plus 5 over x plus 5, okay? All right, so we're going to write this as greater than or equal to 0. Let's scroll down and get some room going. So we'll start here on the left. We have 7 times x, that's 7x. And then plus 7 times 6 is 42. And then let's just keep going. I'm going to put a minus here, and I'm going to put a bracket. Again, I'm subtracting everything away from there. So I've got to be very careful about my sign. Okay, so that's why I put the bracket there, just to make sure I don't make a silly sign mistake. So 8 times x is 8x. And then plus, you've got 8 times 5, that's 40. You can close the bracket now. And let's write this over. We've got our common denominator, which is x plus 5. Times, we've got our x plus 6. Again, this is greater than or equal to 0. All right, let's get some room going. All right, so in the numerator, let's go ahead and distribute this negative to each term. And I'm just going to write it as a negative 8x and then a minus 40, okay? When you remove the brackets like that and you have a negative out in front of it, you've got to change the sign of each term inside. Okay, so in the numerator, 7x minus 8x is negative x. And then 42 minus 40 is plus 2. Again, this is over my common denominator of x plus 5 and then times x plus 6, okay? And let me extend that a little bit. All right, so this is greater than or equal to 0. So I'm going to copy this. All right, so now what we want to do, since we have a rational expression on one side and 0 on the other, we want to set the numerator equal to 0, solve that equation. We want to set the denominator equal to 0 and solve that equation. So if I set the numerator equal to 0, I get negative x plus 2 is equal to 0. I'm going to subtract 2 away from each side of the equation. And this cancels, so I get negative x is equal to negative 2. So at this point, you can multiply both sides by negative 1, divide both sides by negative 1. Doesn't really matter. Let's just divide both sides by negative 1. And the negative here cancels with the negative 1. So you have x by itself on the left. On the right, negative 2 over negative 1 is 2. So x equals 2 solves the equation you set up from your numerator. So off to the side here, I'm going to say we have x equals 2, and I'm going to say that this is from the numerator, okay? That's important because we have a non-strict inequality here. So because 2 makes the numerator into 0, think about that. 2 makes the numerator into 0. It won't make the denominator into 0. So 0 divided by something that's not 0 is 0. So if you think about the left side here, this inequality is going to say what? It's going to say that 0 is greater than or equal to 0, which is true, okay? So this guy, 2, will be a solution for this rational inequality, all right? So now let's think about the denominator. So we have x plus 5, that quantity, times x plus 6, that quantity. And we're setting this equal to 0. Now it's in factored form, so we can just use our zero products property, and we can set each factor equal to 0 and solve. So I'm going to have that x plus 5 is equal to 0. I'm going to subtract 5 away from each side of the equation. That will cancel. I'll have x is equal to negative 5. So one of the solutions will be x is equal to negative 5. The other solution comes from the factor x plus 6. So x plus 6 is equal to 0. Let's subtract 6 away from each side of the equation. And again, this is going to cancel right here. So we'll have x is equal to negative 6. Okay, so we specifically want to state that these guys right here are from the denominator, okay? The reason we want to state that is if I plug in a negative 5 for x here, think about this. Negative 5 plus 5 is 0. 0 times whatever this would be is 0. That means I'm dividing by 0, and that's undefined. So this negative 5 here and this negative 6 here will not be solutions. Because again, they make the denominator into 0, and division by 0 is undefined, okay? So this guy right here, this 2, is the only endpoint that will satisfy the inequality. All right, so let's go ahead and copy these kind of endpoints or boundaries or critical values or whatever you want to call them. And we're just going to set up some intervals. So everywhere I see one of these boundaries, I can just put a vertical line to kind of split up the number line into my intervals. So at 2, I'm just going to put a vertical line here. At negative 5, I'm going to do the same. And at negative 6, I'm going to do the same, okay? Doesn't have to be perfect, just a visual representation of what's going on. And I like to label the intervals with capital letters. You don't have to do that. You can do whatever you want. But it just makes it easier for me to keep track of what's going on. So this will be interval A, and that'll consist of the numbers that are less than negative 6. Between negative 6 and negative 5 will be interval B. And then greater than negative 5 but less than 2 will be interval C. And then anything larger than 2 will be interval D. What we want to do now is very, very easy, but also very, very tedious. We want to write the original inequality, which was 7 over, we had x plus 5. And this was greater than or equal to, we had 8 over x plus 6. So we want to take a value from each interval, plug it in, and see if it works, okay? So let's start with interval A. I'm just going to choose negative 8. And if I plug that in for x, what would I get? So I would have 7 over negative 8 plus 5 is greater than or equal to 8 over negative 8 plus 6. So negative 8 plus 5 is negative 3. So this would be negative 7/3. And then negative 8 plus 6 would be negative 2. Okay, so this would be negative 2. We know that 8 over negative 2 is negative 4. So ask yourself the question, you have negative 7 over 3. Is that greater than or equal to negative 4? Well, one way you can figure this out if you have absolutely no idea, remember, you can check to see if one fraction is larger than another by cross multiplying. So I could write this as negative 7 over 3, question mark. I'm going to write this as negative 4 over 1. Go ahead and cross multiply. So 3 times negative 4 is negative 12. 1 times negative 7 is negative 7. Now, the larger number, okay, the larger product, you could say, if you want to be more specific, is next to the larger fraction. Now, this is reversed because we're working with negatives. So this guy right here, negative 12, is larger in terms of absolute value, but because we're working with negatives, that means the negative 4 part is the actual smallest number, right? If these were positives, this would be positive 7, this would be positive 12. We could say 4 is larger than 7/3. But because we have negatives, the reverse is true, because what we have is a larger negative, which means we have a smaller number, okay? So that means negative 7/3 is greater than negative 4. So this is true, okay? This is true. So that means anything in interval A is going to work, okay? So we can just write a T in that interval, and it's kind of busy there, but let's just write it down here. Let's put a T for true, okay? So anything in interval A will work. You can even write it off to the side and say interval A, we'll put a T, okay? Just so we can keep track. So for interval B, I'm between negative 6 and negative 5. So let's use negative 5.5. We'll just do that in decimal form. So 7 over, we have negative 5.5 plus 5. We know that would be negative 0.5, right? Negative 0.5. So what am I really asking there? 7 divided by negative 0.5 is the same as 7 divided by negative 1/2. We know that would basically be 7 times negative 2. So this is negative 14. Okay, this is negative 14. All right, this is greater than or equal to. If I plugged in a negative 5.5 here, negative 5.5 plus 6 is 0.5. So 8 divided by 0.5, again, is the same thing as 8 divided by 1/2, which is the same thing as 8 times 2, which is 16. So is negative 14 greater than or equal to 16? No, this is false. This is false. So we can say that for interval B, it's false, right? Nothing's going to work. All right, let's look at interval C now. So we have 0 there. 0 is really easy to work with, so let's just choose that. We have 7 over 0 plus 5 is 5, is greater than or equal to 8 over 0 plus 6 is 6. You can reduce 8 6 if you want to. Divide each by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. Now, again, I don't know off the top of my head if 7/5 is a larger value than 4/3. I know it's not equal to 4/3, but again, I can check by cross multiplying. So 7/5 and 4/3, put a question mark there. 5 times 4 is 20. 3 times 7 is 21. Again, the larger product is next to the larger fraction. So in this case, 7/5 is larger because 21 is larger than 20. So this is a true statement. This is true. 7/5 is greater than 4/3. So for interval C, we can say that it's true again, right? So let me put a T here. And I forgot to put an F here, but let's go ahead and put that in now. Okay, so now we just have interval D left. So let's go ahead and check that. And I'm just going to pick the number 6. Easy to work with. So 7 over 6 plus 5 is 11. So 7/11 is greater than or equal to 8 over 6 plus 6 is 12. If I have 8/12, I can reduce that. 8 divided by 4 is 2. 12 divided by 4 is 3. Okay, so that becomes 2/3. Again, if you don't know which one's larger, go ahead and set this up and cross multiply. 7/11 question mark 2/3. 11 times 2 is 22. 3 times 7 is 21. 22 is a bigger number, so 2/3 is the bigger number. So 7/11 is not going to be greater than 2/3. So this is false. Okay. So this is going to be interval D. So this is false. Let's put an F here. Now, recall that this guy right here is going to be a solution for our inequality, and the other endpoints will not be, right? Because they make the denominator 0, okay? So for our solution region, remember, A works, that interval, so anything less than -6, but -6 is not included because it makes the denominator 0. So x is less than -6, and again, strictly less than. Then or, we also have this region here between -5 and 2, where 2 is included, but -5 is not. So we could say that -5 is less than x, which is less than or equal to +2. Okay, so this is our solution. We can also write this in interval notation as the union of the two intervals. So we can say from -infinity up to but not including -6, and the union with, you have anything larger than -5, again, -5 is not included, out to and including +2. 2 is included, so you get a bracket there. Now, we can go ahead and graph this on the number line. Let's erase all this. Again, anything less than -6 works. So I'm going to put a bracket at -6 and shade everything to the left. And then between -5 and 2 with only 2 included. So -5 and 2. Again, bracket at 2, parenthesis at -5, and just shade everything in between. So there's your solution graphically. There's your solution in interval notation. And here it is just using our variable x. So again, x is less than -6, or x is greater than -5 and less than or equal to 2. All right, let's take a look at another one. So we have 2x squared minus 9x minus 5 over x squared minus 9, and this is less than 0. So because we have a strict inequality here, none of the endpoints are going to be solutions, okay? Because it's strictly less than. So what I want to do here, since I have a rational expression on one side and 0 on the other, I can move into the second step, which is just to set the numerator equal to 0 and solve, and the denominator equal to 0 and solve. So for the numerator, I've got my 2x squared minus my 9x minus 5 is equal 0. This is pretty easy to solve using factoring. You can also use the quadratic formula. Whatever's easiest for you is what you should do. For me, I can just factor this pretty quickly. And the reason I say that is because this guy's a prime number. So I know I can kind of get through this really fast. So this is a 2x, and this is an x. I need to figure out this and this, but that's pretty easy because this guy right here is a -5, okay? So that means that it can only come from -1 times +5 or +1 times -5, okay? Now, because I want a middle term of -9x, I know that I'm going to put my -5 here and my +1 here. Because the outer would be -10x and the inner would be +x. Okay, that would give you the correct middle term, again, of -9x. All right, so we can solve this using our zero product property. I can set 2x plus 1 equal to 0. Let me kind of scooch this down. And I can solve this. So -1 on each side of the equation. We know that this cancels. You'll get that 2x is equal to -1. Divide both sides of the equation by 2. And we'll cancel this 2 with this 2. X is equal to -1/2. Okay? So let's put this over here. We'll put x is equal to -1/2. You don't really need to specify that this comes from the numerator because, again, you have a strict inequality. It's not going to work as a solution. So let's erase this. Let's look at the other factor there. So we have x minus 5 equals 0. Add 5 to both sides, and we get that x is equal to 5. So my solutions here will be that x equals -1/2 and then also 5. All right, let's think about the denominator now, which is really easy to work with. We have x squared minus 9. So that's the difference of two squares. If you want, you can factor that and solve it, or you can also use your square root property, whatever's faster. So if we have x squared minus 9 equals 0, again, you could factor this, but it's even quicker to say x squared. If I add 9 to both sides, we'd say it's equal to 9. By square root property, we know that this comes to x is equal to plus or minus the square root of 9, which is 3. Okay? So for the denominator, we get x is equal to +3 and -3. Okay, those are our solutions. So let's grab this and go to our number line, and we'll just set up these intervals. So -1/2, we don't have a notch for that, but that's halfway between 0 and -1. So let's just say that's about right there. So I'm going to label that as -1/2. So you've got that as a visible boundary. So let's put a vertical line there. You've got 3. You've got -3. And you've got +5. Okay? So what I'm going to do again is I'm going to label these with capital letters. So I'm going to say this is A, anything less than -3. I'm going to say that B is anything greater than -3 and less than -1/2. I'm going to say that C is anything that's greater than -1/2 and less than 3. I'm going to say that D is anything that's greater than 3 and less than 5. And I'm going to say that E is anything larger than 5. Okay, so the original inequality, we had our 2x squared minus 9x minus 5 over, you've got your x squared minus 9, and this was less than 0. Okay, so a lot of stuff to check here. In interval A, let's just grab -6. So I would have, we'll have 2 times, you'll have -6 squared, which is 36. And then minus 9 times -6. So -9 times -6, you can go ahead and do that now. That's 54. So plus 54. And then minus 5. So 2 times 36 is 72. So you would have 72 plus 54, which is 126. Then if I subtract 5 away, I get 121. So this would be 121. Then this is over. If we squared -6, you get 36. And then 36 minus 9 is 27. Now, it doesn't matter what this value actually is. Is it less than 0? No, it's a positive number, okay? So in interval A, it's false, right? Because this doesn't work. This is false. So we'll put an F in interval A, and then we'll go ahead and say that interval A here, this is going to be false. All right, in interval B, let's go ahead and grab -2. So I would have 2 times -2 squared minus 9 times -2 minus 5. This is over. -2 squared, let's just go ahead and do that. That's 4. 4 minus 9 is -5. Now, if you go through here, -2 squared is 4. 4 times 2 is 8. So this is 8. You've got a -9 times a -2, which is 18. So this is plus 18 and then minus 5. So this is supposed to be less than 0. Now, what you can tell here is that this guy is going to be positive in the numerator and it's going to be negative in the denominator. So a positive over a negative is going to give you a negative, and a negative is always less than 0. So interval B here we can say is true. For the sake of completeness, we can go ahead and do this. 8 plus 18 is 26. 26 minus 5 is 21. So you would have 21 over -5, which again is a negative number, and that's going to be less than 0. So for interval B, let's put true. Okay, so this works. All right, for interval C, let's pick 0. So if I plugged in a 0 for x, this would be gone, this would be gone, and this would be gone. You would have -5 over -9. Well, what happens is negative over negative is positive, and that's not less than 0. So in interval C, it's false, right? It does not work. All right, for interval D, let's plug in a 4. So I would have 2 times 4 squared minus 9 times 4 minus 5. This is over. 4 squared is 16. 16 minus 9 is 7. So 4 squared is, again, 16. 16 times 2 is 32. So this is 32 here. And then we have a -9 times 4, which is -36. So this is minus 36. And then minus 5. So this is supposed to be less than 0. So 32 minus 36 is -4. And -4 minus 5 is -9. So you would get -9/7, which is less than 0. So this is true. So for D, we'll say this is true. Okay, so let's check something in interval E now. And let's just choose 6. So we have 2 times. We've got our 6 squared minus 9 times 6 minus 5 over. 6 squared is 36. 36 minus 9 is 27. So is this less than 0? Well, 6 squared again is 36. 36 times 2 is 72. So this is 72 here. -9 times 6 is -54. So this is going to be minus 54. And then you have minus 5. So 72 minus 54 is 18. 18 minus 5 is 13. So 13/27. Again, this is a positive number. It's not less than 0. So for E, this is going to be false. Okay, this is going to be false. Okay, so let's go ahead and write our solution. Remember, this is a strict inequality, so none of the endpoints are going to work. So we know in interval A it doesn't work. In interval B it does. So that's between -3 and -1/2. So x is greater than -3 and less than -1/2. Okay, so that's one part of it. So then we're going to say or here. We also have this region between 3 and 5. So x is going to be greater than 3 and less than 5. So these are the two intervals that work or that satisfy your rational inequality. In interval notation, I can say that we have from -3 to -1/2, again with neither included, and it's the union with you have between 3 and 5, again with neither included. So graphically, let me erase all this, and let me write my notch in for -1/2 again. So I'm going to go ahead and put a parenthesis at -3 and a parenthesis at -1/2. Again, shade everything in between. I'm going to put a parenthesis at 3 and a parenthesis at 5 and shade everything in between. So this is our graphical solution. This is our interval notation. Again, using our variable x, we say x is greater than -3 and less than -1/2, or x is greater than 3 and less than 5. All right, let's take a look at another one. So we have 6x squared plus 7x minus 24 over x cubed minus 6x squared plus 12x minus 8. This is greater than or equal to 0. Okay, so it's already in the format of a rational expression on one side and 0 on the other. So that means we can basically move into the second step, which is to set the numerator, which is 6x squared, plus 7x minus 24 equal to 0. We'll also set the denominator equal to 0, but let's just take care of this one first. So for this guy right here, it's a little bit more challenging to factor it because we have a non-prime number here, right, and a non-prime number here. So 6, and you can think about -24 or 24 if you want to think about it like that. Those are both composite numbers, right? So it takes a little bit more effort to factor there. So let's just use our quadratic formula, because in this case it'll be a little bit quicker. At least it is for me. So this is my A, this is my B, and this is my C. So hopefully you remember your quadratic formula. It's x is equal to, you've got the negative of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm just going to plug in. So I have negative b, so that's -7. Then I have b squared, so that's 7 squared. Then I have a times c. A is 6, and c is -24. And then 2a, I've got 6 for a. So 2 times 6 is 12. I'm going to get rid of that. 7 squared is 49. -4 times 6 is -24. -24 times -24 is 576. So this is plus 576. And then 49 plus 576 is 625. Okay, so the square root of 625 is 25. So that's pretty easy. So we have two solutions here. You've got x equals -7 plus 25, which is going to be 18 over 12. So one solution is that x equals 18/12. You can, of course, reduce this. Each is divisible by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. So one solution is x equals 3/2. Another solution is we have -7 minus 25, which is -32. And then this is over 12. So I can reduce this by dividing each part by 4. 32 divided by 4 is 8, so that would be -8 there. 12 divided by 4 is 3. So you've got 3/2 and -8/3. So this is for the numerator. And we want to specifically mark that it's from the numerator because we have a non-strict inequality here. We have this greater than or equal to. So these guys will work as solutions. Okay, so let me just kind of move this up here a little bit. And we're just going to say that this comes from our numerator. Okay, and let me kind of tighten this down a little bit. So we have 3/2 and again, -8/3. All right, so now we want to set the denominator equal to 0. So we have x cubed minus 6x squared plus 12x minus 8 equals 0. So you might pause for a minute and say, how in the world are we going to solve this? This is not a quadratic equation. This is not something we learned how to solve. Right? We'll talk about these types later on in the course when we talk about the rational root theorem. But for right now, you can't solve this by factoring it by grouping.
right? That's what you might start out by thinking. Okay, I'm going to factor this using grouping. It's a 4-term polynomial. But in fact, you have to remember that this comes from the special factoring lesson. This guy right here would factor into a binomial, which is going to be x minus 2, and that quantity cubed, right? If you went through this and expanded it, you would get back to this, okay? So this is equal to 0. Now, the cool thing about this is that you have basically x minus 2 times x minus 2 times x minus 2. So if you use the zero product property, you only get one solution, right? You get x minus 2, you set that equal to 0, you add 2 to both sides of the equation, and you get that x is equal to 2, okay? So from the denominator, we get that x is equal to 2. And again, that right there will not satisfy the inequality, right? You'd be dividing by 0, and that's not allowed. So let's copy these and bring them to the number line. All right, so let's go ahead and set up our intervals on the number line. So 3 halves is basically 1.5. So let's say that's about right there. And negative 8 thirds is going to be negative 2 2/3. So let's say that's about right there. Okay, so that's negative 8 thirds. Okay, so let's go ahead and make some vertical lines here. So I'm going to go ahead and put one here and also here. And this is going to be tight, but I also have to put one here at 2. Okay, so my interval A will be anything that's less than negative 8 thirds. My interval B will be anything between negative 8 thirds and 3 halves. Then my interval C, this is going to be a tight one, is anything between 3 halves and 2. And then interval D will be anything larger than 2. Okay, so let's pick a test value from each region here. And my original inequality, again, was 6x squared. We had plus 7x. We had minus 24. And this is over. We'll have x cubed minus 6x squared plus 12x minus 8. But again, in factored form, I'm just going to put this as x minus 2, that amount cubed. And this was greater than or equal to 0. Now, to save time, I'm just going to put some parentheses wherever there's an x, just so I can quickly substitute things in. And let's put some parentheses here. Okay, so in region A, I can choose something like negative 4. So let's plug in a negative 4 here, and here, and here. So negative 4 squared is 16. Let me kind of scroll down a little bit. So negative 4 squared, again, is 16. 16 times 6 is 96. And then you would have 7 times negative 4 is minus 28. And then minus 24. So 96 minus 28 minus 24 is 44. So you would have 44 in the numerator. In the denominator, negative 4 minus 2 is negative 6. Negative 6 cubed is negative 216. So we don't need to go through and reduce this or anything like that. We know that this value is negative, and a negative is not greater than 0. So this guy is going to be false. Okay, so this is false. So we can say that interval A is going to be false, right? Nothing's going to work here. For interval B, I have 0, so that's pretty easy to work with. So essentially, this would be 0, this would be 0, and this would be 0. So you can go ahead and say this is gone, and this is gone. So you would end up with negative 24 in the numerator. In the denominator, you would have negative 2 cubed, which is going to be negative 8. So you've got negative over negative, which is positive, right? It ends up being positive 3. So 3 is greater than or equal to 0, which is true. So this guy is true, so interval B is true. For interval C, you've got a real tight window. You've got between 3 halves, or 1.5, and 2. So what you can do is you can take 1.75. So I'm going to take 6 times, and I'm going to plug that in here. I don't really have enough room, so I'm just going to do it right here. So 6 times, you've got 1.75 squared plus 7 times 1.75, and then minus 24. Okay, then this is over. You're going to have 1.75 minus 2. So 1.75 minus 2, this is going to be cubed. Okay, so let's kind of scooch this over here so we have some room. We want to say this is greater than or equal to 0. So 1.75 squared is going to be 3.0625. If I multiply that by 6, I get 18.375. So let's put 18.375, then plus 7 times 1.75 is 12.25. So if I add those amounts together, I'll get 30.625. So 30.625. And then minus 24. So the main thing here, forget about the number. You know that it's going to be positive. So let's just say the sign in the numerator is positive. In the denominator, I know this guy's going to be negative, right? So 1.75 minus 2 is basically negative 0.25. If I cube that, I'm still going to have a negative. So positive over negative is negative. A negative is not greater than 0. So this guy's going to be false, okay? This guy's going to be false. So for region C, we can put an F for false. Okay, one more region to check. We need to look at region D. So for region D, let's just go ahead and pick 4. So we'll plug that in there, and there, and there. So 4 squared is 16. So you would have 6 times 16, which is 96, plus you'd have 7 times 4, which is 28, and then minus 24. So if I did 96 plus 28 minus 24, I'd get 100. So the numerator here would be 100. For my denominator, 4 minus 2 is 2. 2 cubed is 8. So forget about the fact that you could reduce this. This is going to be greater than 0. It's a positive number. So this guy is going to be true. Okay. And I forgot to write false here. It's kind of hard to squeeze it in, but let's put an F there. All right, so we know what our solution is now. We've gone through all the possibilities. We can say that anything in region B, so that means x is going to be greater than, in this case, or equal to negative 8/3, and less than or equal to, in this case, 3/2. Again, I included the negative 8/3 and the 3/2 because those were from the numerator, okay? Then or, the other scenario where it's true is anything larger than 2. So x is greater than 2. But I don't include this endpoint here because this came from my denominator, makes the denominator 0, so it's going to be excluded. So in interval notation, we have between negative 8/3 and 3/2 with each included, so I use a bracket next to each. And it's the union with anything larger than 2, so a parenthesis next to 2. Again, this goes out to positive infinity. So let's graph this. So again, we said negative 8/3 was about right here, and we said 3/2 was about right here. So we're going to put a bracket for each of these. So a bracket there and a bracket there, shade everything in between. And then we know where 2 is, that's right here. I'm going to put a parenthesis there because it's not included. Let me make that a little bit better. And I'm just going to shade everything to the right. So this is my solution graphically. Then this is my solution in interval notation. And then using my variable x, I can say x is greater than or equal to negative 8/3 and less than or equal to 3/2, or x is greater than 2.